So what we start off with is a 3D scan of you. How large is your biceps? What shape is your leg, for example? What are the dimensions? We can extract that from a 3D scan. Then we take this information, you transform it into a 2D plane. That 2D device is then printed on a 3D printer. Then it is assembled, which means that we just transform it into a 3D object. So if you look at this particular device, you can see if I transform that into this particular shape, it allows us to, for example, form a taper. And then we have a ready-made device that can be at various locations of the body. It can be on the arm, for example, it can be on the leg, depending on the application. My name is Philipp Gutruf. I'm an assistant professor of biomedical engineering, Craig and Burge faculty fellow at the University of Arizona. So my lab, what we do is we create devices that intimately integrate with biology, with us, with the human body. We have two areas. One is wearables and the other is implantable devices that allow us to really capture what the body is doing in detail with very high fidelity. I think it's easier for fabrication, right? Yeah. So the Bluetooth I expect would be a little bit larger, maybe the size of this one with the new antenna design.
This guy.
So for our wearable devices specifically, what we needed to create is a device that's ultra lightweight, soft like your skin, that conforms to your body really well. And that's why we pioneered the use of 3D printing and 3D scanning to create devices that are tailor-made for each individual. Specifically, when we make these devices, we insert electronics into this and continue the printing process to completely encapsulate the electronics. And what you will see in these devices is these repeating serpentine shapes that allow us to create electronics that stretch and bend. There's nothing really like this out there at this point in time. We try to make the form factor and the mechanics and the feel of the device more like biology. Having extra information from the human body allows us to make quicker diagnosis of disease. We can get more information about somebody, tailor medicine to an individual person, which then allows us to, for example, give less of a drug, have less side effects, for example. These are all things that these type of devices are really useful for. Another application area is certainly human performance. We can extract, for example, really small fluctuations in temperature. We also have the capability to look at muscle deformation, so we can see how much effort is put into that particular muscle of the body during exercise. This is all feedback that you don't get from conventional wearable devices, even the ones that pro athletes are using. As biomedical engineers, we always try to improve the current state of technology. And if you just look at the extrapolation and the speed that technology is developing, we as humans will be very quickly the weak link, right? So I think really creating a link between technology and the human body will become critical in the future. I would really like to make an impact not only in academia. I would like to see these devices being used by people every day. I think that's the ultimate reward for a researcher, right? To really see that fundamental research that then ultimately translates into a product that many people are using and gathering a lot of benefit from. That is something that we in general are striving to achieve.